Hello again. Today we will talk about work energy and power. Both of these are scalars quantity. So these have a magnitude without a direction. The work is the force multiplied by the distance in the same direction of the force. Okay? So work equal force multiplied by distance. Now, work equal force multiplied by distance, Newton dot meter. Newton is the force, which is mass multiplied by acceleration, mass kilogram, acceleration meters per second squared, multiplied by meter, so kilogram meter squared s minus 2. So the work, which is measured in joules, have the SI base unit of kilogram meter squared S minus 2, which is the same unit of energies. And it's a scalar as other energy. So the work done is the force multiplied by the distance moved by the force in the direction of the force. Here we have a force moving up and the distance up, so we have a work. Now, if the force is in the opposite direction of the motion, like a car moving forward and you press on the brake, so no driving force, we have only frictional force, and this is the direction of the movement. Also we have a work, but a work here but have a negative sign because the force and the distance in opposite directions. Okay? Now, to make it easier, we use the relation force multiplied by distance but multiplied by cosine angle between the force and distance. If the force in opposite direction of the distance, the angle is 180. So cosine 180 is negative 1. What if we have an object held by a student and the student moving forward, this is the distance, and he acts by a force upward. So the angle between force and distance is 90 degree. So work equal force multiplied by distance multiplied by cosine angle between distance and force, which is 90. Cosine 90 is 0, so the work done is 0. So if you handle an object between your hands and you moving forward or backward, the work equals 0. You just act or have a work when you moving the object upward or moving the object downward. So the force parallel to the direction of the movement. If we have an object moves in a circular motion, okay, the work done in the object equal force multiplied by distance. The force is towards the center and the distance is in the tangent direction, okay, so the angle here is 90. So the work on an object moving in a circular path is also 0. Or we can use the relation that work equal change in kinetic energy. Change in kinetic energy, which is half multiplied by mass by final speed squared minus initial speed squared. And in a circular motion, we know that the speed is the same, but the velocity changes. So here again, the change in kinetic energy is 0, and the work done is 0 as well for the object moving in a circular path. Here we have an object and a force acting on it by an angle of 25, and the object moves forward. So the work done equal the force 1.5 multiplied by distance, which is 265 centimeters multiplied by cosine angle. You have to remember that you have to change this distance from centimeter to meter by divided by 100. Why? To have the unit joule. Okay? In your exams, the unit is given, so you have to change the value depending on the unit the examiner wants the reading measured in it. Now, what about the work done by an expanding gas? Here we have a gas inside this piston and we have a force acting on this gas. So this is the initial volume of the gas. If we add a force, so the piston will move inside. So this is the new volume. Okay, so we have a change in volume, which is V2 minus V1. Okay, as the volume decrease, the pressure increase. Okay, now if we take pressure multiplied by area, it's have to be equal to force, as we know from the beginning. Now, what is the relation between the work done on the gas, pressure and volume? Work done equal force multiplied by distance. Force equals pressure multiplied by area. And this is the distance traveled. Distance multiplied by area, this is the distance traveled, and this is the cross-sectional area, which is the change in volume. Let's make it again. Work equals force multiplied by distance in the same direction. Here the piston and here the gas particles inside. If you push this piston till here, so this is the distance traveled by the gas, and this is the cross-sectional area. So the change in volume equal area multiplied by distance traveled by the piston. Now pressure equals force over area, so force equals pressure multiplied by area, and this multiplied by distance. Area multiplied by distance, it is the change in volume. So the work equal pressure multiplied by the change in volume. Now, the volume measured in meter cube. Pressure Newton per meter squared. So we have Newton dot meter, which is force multiplied by distance, which is the work, which is equal to joule. So you can see that the unit is the same, whatever the value is used. So the work done equal pressure multiplied by change in volume. Here we have a sample of gas that has a volume. This is V1. The gas expands at a constant pressure of, this is the pressure, so that the volume becomes, this is the final volume. So we can find the change in volume, calculate the work done on the gas during the expansion, change in volume, this is the value, and we can change it from centimeter cube to meter cube by multiplying it by 10 to the negative 2 cube. So this is the new volume, and multiply it by the pressure in Pascal, we have the work done in joule. Okay, now anybody can do work, it must have an energy. If we have an object at a height, this object have potential energy, so this object can make a work, okay, or can make an energy. Now, these are the order of magnitude of energy the burning image, we have about 1000 joule of energy. Radioactive decay, about 10 to the negative 13 joule energy. No need to remember these values, okay? This values just to understand how much energy from each type of values, and all of these can make work done. Like an earthquake, the energy is 10 to the power 19, okay? And sure, this depends on the amount of the earthquake or the strongest of the earthquake. Energy conversion and conservation. As we know that energy can change from type to another, and energy cannot be created or destroyed. It can only be converted from one form to another. This is the law of conservation of energy. What types of energy we have? We have a gravitational potential energy, which is the energy depending on the height in a gravitational field. Kinetic energy, it is the energy according to the motion of the object. Elastic potential energy or strain energy, it is the energy stored in stretching or compressing an object. Electrical energy, it is energy in a moving charge, like current. Electrostatic potential energy, it is energy due to position of a charge in an electric field. If we have positive and negative plates, this is the electric field. So the position of the charge play an important role in find the electrostatic potential energy. Sound energy, we have an energy in the sound, and it's a travel from a place to another. Sound can't travel through vacuum. Electromagnetic radiation, we have a big family of electromagnetic radiation. Visible region, we have infrared and ultraviolet, we have X and gamma ray, and here we have the micro and radio waves. All of these are the electromagnetic radiation, energy associated with waves in the electromagnetic spectrum. Okay, this is the electromagnetic family or spectrum. Solar energy, it is the energy from the sun, which is a renewable energy. Internal energy, it is the energy inside the material, and it is random inside the material, like a nuclear material. It is a random kinetic energy and potential energy of the molecules. Okay, this is very important definition. Chemical energy, it's energy from chemical materials and chemical reaction. Nuclear energy, it is energy from the particles in the nuclei of atom. Thermal energy, it is energy transferred due to temperature difference from side to side. Now, kinetic energy equal half mv squared. What is the relation between kinetic energy and equations of motion and work as well? We have v squared equal u squared plus 2as, which is equation of motion. If we multiply this value by half m, we multiply both sides by half m, and this will be multiplied by this and this because we have a positive or add sign here. Okay, now we have half mv squared equals half mu squared plus half m2a displacement. Now take this to the other side. We have half m v squared minus half m u squared equals 2 with 2. We have here ma multiplied by displacement. So we have here a change in kinetic energy on this side, half mv squared, final kinetic energy minus initial kinetic energy. Mass multiplied by acceleration, it is the force. Displacement, which is the distance. Force multiplied by distance, which is the work. So the work is another form of kinetic energy, or any object have a kinetic energy, so this object can do a work. On another side, if we have an object and we move the objects upward, so the work done equal force multiplied by distance. If you want to move this object upward by a constant speed, so the force moving up have to be equal to force down, which is the weight. So the force acting is mass times the gravity. The distance traveled between the starting point till end point is the height. So we have mgh equal the work, okay, which is the potential energy or the change in potential energy. So the kinetic energy have a relation with the work, it's equal to the work, and potential energy as well have a relation between work and mgh. Potential energy, it is the ability of an object to do work as a result of its position or shape. What is the meaning of or shape? If we have a spring like this and you add a force, so its length will decrease. So we have elastic energy. So the change in shape produce an elastic energy. If you want to take the objects up, so we have a work, the work equal the weight of each object multiplied by distance. If you want to find the total work, you have to multiply this value by number of cans, so you can find the total work done. Okay, efficiency. Efficiency, it's a good way to have the relation between output energy to input energy multiplied by 100%. Output power to input power, or output energy to input energy. Okay? All the time, the efficiency value will not be equal 100%. All the time, the amount of efficiency must be less than 100% efficient. Why? Because there is a lot of energy lost, maybe to surrounding, maybe in moving the object from place to another. So the efficiency gives a measure of how much of the total energy may be considered useful and is not lost. Useful energy output over total energy inputs. Let's see this example. A man lifts a weight of 480 Newton, vertical distance 3.5. So the work, you have multiplied this by this. Using a rope and some pulleys, the man pulls the rope with a force of 200 Newton and length of 10.5 meter of the rope passes through his hand. Calculate the efficiency of the system. So the work done by the man is the force multiplied by distance moved, and the work done lifting the load is 480 multiplied 3.5. Okay? Divide the output energy by input energy, or output work by input work. You see that the efficiency is just 80%, which is a good value. It's not a bad value. Okay? Most of the cars efficiency is less than 65%. Power. Power, it is the ratio of energy per unit time or work done per unit time. Time measured in second, work in joules. So the unit of power is watts. Okay? Now, power equal work over time. Work equal force multiplied by distance over time. We have a special case if distance over time equals speed, so force multiplied by speed equal power. This only can be used if the speed of object is constant. Otherwise, you can't use this relation. Okay? So Power equal energy or work over time. Power equal force multiplied by speed if the speed is constant. Here we have some examples of powers. Okay, the hair dryer is about 3000 watts. The loudspeaker output is about 5 watt. We have loudspeakers with a higher power, but its sound will be more than this value. Now, we have a unit to measure the amount of electrical energy used, which is kilometer hour. Kilometer hour is the energy expended when work is done at the rate of 1 kilowatt for 1 hour. So 1 kilowatt hour is 1 kilowatt multiplied by 1 hour. 1 kilo is 1000, hour is 3600 seconds. So we have watt multiplied by second. Watt, it is power, which is energy over time, energy over second, multiplied by second, so I have energy. So the kilowatt hour, it is equal to joule, okay? Each 1 kilowatt hour, it's about this value, watt second, or to 1 joule. Okay, in this way we finish this chapter. Please solve the questions of this chapter and solve more past papers in the next coming days. Thank you. See you later.